So, good morning. We were discussing about the importance of grounding, the electric and magnetic fields in the vicinity of the substation, how to mitigate the fields, particularly the electric and magnetic fields. So, several options for the mitigation techniques were discussed. Now, in this class we will try to see the importance of the communication channel, how the fiber optic is important for the transmission lines, and also how it could be used for the data communication. So, the use of fiber optics with the increase in voltage levels have also been added with the ground wire which is connected to the topmost portion of the tower. So, the main importance of going in for fiber optic cable is helpful, apart from the ground wire which performs the minimum creating a path for the lighting aspect. So, this ground wire, which is overhead ground wire, will also act for the for the communication purpose. So, very important aspect going in for fiber optical communication. So, the main use of fiber optics with transmission lines is to see that proper sensing and detection of electrical faults, and in case of failures, and this data is being given to the SCADA system, that is SCADA supervisory control and data acquisition systems, which will be helpful in taking the proper decisions for eliminating the isolating the line where the failure has occurred. And fiber optics also can be used as a neutral or a grounded connection. Using the fiber optics cable also reduces the electromagnetic compatibility and electromagnetic interference issues going in for a regular cable where these signals could cause an issue. So, with the help of fiber optic cabling, the reduction of electromagnetic compatibility and interferences issue are reduced. And the fiber optics help in communicating, that is data communication from the generating plants to the substations or to the control centers, etc. This will be helpful in proper diagnosing and taking the remedial solutions. And we know that we have discussed about the right of way, which is a very important in case of the tower configuration, and as the high voltage levels of UHV and EHV. So, we use a lot of space for that, that is the extensive use of the right of way could also be used by the utilities, particularly for communication, where line leasing could be carried out. So, this is again an economic advantages for going in for fiber optic communication systems. So, the optical ground wire or OPGW, as it is shown here, is basically a cable. Here you can see the cable here. It is similar to the ground conductor, and the size of the cables here vary depending upon the different voltage levels. You can see several stranded conductors are there, similar to a normal high voltage conductor, and this is used for the overhead ground connection, that is the earthing connections on the top of the towers. So, basically you can see that in one of the slot in the conductor arrangement you have a fiber optical link or a fiber optical cable which is being seen here. This will help in the communication of the data and the information to be sent from the generation to the substation level or to the SCADA centers where this information will be highly helpful. So, we will look into the importance of the optical fiber ground wire and what is the composition of that, how it is being useful for the communication and data transfer, particularly for the electrical utility service. So, optical fiber ground wire is a composite conductor or a wire which basically serves as a conventional overhead ground wire. This is conventional overhead ground wire with the added benefit of providing high capacity and reliable fiber optic communication. So, that is the importance of going in for optical ground wire. You can see the fiber optic link which is embedded into the conductor, that is a overhead ground conductor, which will help in the communication of the data. So, various types of optical ground wires are shown here. You can see depending upon the voltage level, the transmission voltage level, the size of the optical ground wire dimension changes, the diameter it is increased as the voltage level increases. So, you can see here the optical fiber conductors are embedded in the conductors. You can see for various voltage level the size is different, and the optical link which is inside the conductor connected to a topmost tower, that is a earthing conductor, will be helpful for the data communication. So, when you look into the different concepts, we have two concepts here presently. One is the conductor, other is a optical fiber optic cable which is being embedded into the conductor which is being connected in the overhead transmission for grounding aspect mainly. So, fiber optic cables, we know that mainly the concept is because it emits the fiber optic emits light because of the photons present, and because of the photonic effect here in the electric cables or a conductor, the transmission of electricity happens because of the electrons. And we know that fiber optic cables are primarily used for the communication of the data, and in case of electrical conductor or cables, these conductor or cables are primarily used for powering the electrical devices or transmitting the power or distribution the power. So, these are the major two different concepts which are being embedded together for the optical ground wire. So, you see the commonly used presently in the transmission or distribution or which is being employed or adopted the technology maybe of various types. So, some of the commonly adopted fiber optic technology are the number one being the all dielectric self supporting type of technology, that is ADSS, which is one type of commonly used fiber optic link. The second being the wrap tap type, and the third is the optical ground wire. So, these are the three types of fiber optic technology which is being presently used for in the transmission or by the distribution utilities. So, we will look into the importance of the optical ground wire and how it is helpful for us. So, before that, the all dielectric self supporting generally consists of a high fiber count, and it is more economical than the optical ground wire, and it is installed along the electrical transmission lines. So, you can see here the structure of the all dielectric cable which is used for the communication is shown here. It consists basically of a central core which is a mechanical strength member, followed by that you can see the optical fibers which are of desirable numbers. Then you have a buffer tube which is filled adjacent to the fiber communicating cables. Then there is a layer which protects the water entering the fiber optic link, which is shown in orange color here. Then you have a yellow peripheral strength member to protect the other layers which have been mentioned here. Then you have a total outer sheath, that is a polyethylene insulating sheath, which is helpful to see the insulation effect of the entire cable. So, this cable, particularly the optical fiber cable which is used, the all dielectric self supporting type of cable which is used is non-toxic and also safe to handle, that is important. So, it is not it is very easy to handle by the utility engineers. So, we look into the optical ground wire, how important is this. So, you can see the topmost portion of the tower is the optical ground wire which performs the dual functions. Here is this particular optical ground wire which may consist of a similar construction, is primarily used by the electrical utility industries, and as mentioned it is placed in the topmost position of the transmission line or a tower, where it shields all important conductors, particularly from lightning. So, in lightning strikes this conductor will be helpful to see the surge from the lightning or the over voltages developed should be safely transmitted to the ground through the ground earthing electrodes. So, apart from that, it provides a telecommunication path, as mentioned earlier, the optical fiber link of optical fiber cable which is embedded here. This will try to provide the telecommunication path for internal as well as a third party communications through this network arrangement. The optical ground wire, as mentioned earlier, performs a dual function. One is it acts as a functioning cable or a conductor for the diverting of the surges or over voltages during the lightning strike, and also for the communication aspect. So, it is designed basically to replace the traditional static or a shielded earth wires which we normally earlier which were employed for the overhead transmission. This has an additional benefit which contains the fiber optic cable for telecommunications as well. So, the optical ground wire must withstand mechanical stresses because this is embedded in the conductor. So, mechanical stresses it has to be able to withstand which are generally applied to the overhead conductors or cables, and also it has to withstand to the environmental factors such as wind, the ice loading and any other contamination effects. Apart from these mechanical and environmental stresses, the optical ground wire must also be able to handle electrical faults which could which the network see on the transmission line, and these faults should be able that the optical ground wire will provide a path to the earthing or a grounding system without damaging this fibers, that is optical fibers which are inserted in the cable. So, very important, the faults should be diverted to the outer periphery of the grounded electrode without damaging the inside fiber optic cable. So, few issues related with the optical ground wire, as mentioned earlier, apart from the environmental mechanical environmental conditions, the mechanical stresses, the electrical stresses inside it has to be able to withstand. So, further contamination or pollution which occur because of the activity in the field, the fertilizer spray or the pesticide spray, and also due to the exhaustive emissions. This could be because of the burning kilns near the transmission lines where the emissions could interact with the cable, and in some cases if the transmission lines could also be affected with the salt fog pollutants. So, the contamination is an issue where this could be a problem to the optical ground wires. Then the space potential. So, there could be a electrical potential which could be induced on the fiber optic cables because of the interaction with the phase conductors which are sometimes nearby to the optical ground wire, where the rise in potential could again cause the space potential on the conductor, and this could be an issue with the using of optical ground wire. The formation of dry band arcing. So, we have discussed about the dry band arcing or the partial arcs or the scintillations which are normally caused by the induced currents, particularly during the conditions like fog, drizzle, wet or rain conditions. Here on the conductor surface the contaminants spread over a period of time because of several activities, and because of the wet conditions the uneven distribution of the pollutants on the surface could lead to the current which flows because of the induced effect, and the appearance of wet and dry conditions or bands on the surface can create a dry band arcing or a partial arcs or scintillations. This again could cause currents to flow on the optical ground wires. So, this is an example of how between the two towers the conductors which are connected. One example is all dielectric self supporting cable, that is optical cable, which is being connected for communication purpose. You can see here in case typically the conductor sags between 2 to 5%. So, during that period there is a chance of because of the wind and other conditions. So, likely induced potential on the surface of the optical all dielectric optical cable. So, this would create a potential on the surface in the range of sometimes tens of kilovolts. So, these induced voltages can go up to tens of kilovolts, and further depending upon the contamination on the surface and due to rain or fog or drizzle there could be formation of wet and dry bands, and this causes the dry band voltages further flow of currents on the surface, and sometimes this could cause a powerful electric fields also depending upon the induced voltage levels and the voltage level of the transmission system. So, the space potential effect has to be properly considered, and it has to be mitigated. Then as the dry band arcing is again caused by the space potential as mentioned and here the frequency of the currents in the cable or a conductor depends upon the type of potential, the magnitude of the potential, and how much is the induced current during the wet or the moist conditions. So, because of the dry and wet bands which are formed on the surface, and because of the induced currents, there could be a small arcing which are known as a dry band arcing. So, this dry band arcing could be a continuous, or it depends on the potential and the induced currents. So, this type of dry band arcing is generally observed in wet environments, and because sometimes these voltage or currents which are induced could be very high, and the currents sometimes could be as low as 1.5 milliamperes also. So, these are the concerns pertaining to the optical ground wire which is being used as a dual service, which is for the communication as well as for the earthing aspect. So, that was about the importance of going in for optical ground wire, advantages of that. So, now we see the role of communications systems, particularly in the power transmission or distribution substations and networks. These communication systems play a very important role in the transmission and distribution networks. So, power transmission and utility communication networks both have been the development of telecommunication technologies which have been driven by the need of public telephone operators as well as the corporate networks. So, however, the communication requirements of utility network and public telephone or telecom networks depends very significantly from the utility perspective. When we closely monitor typical power utility communication infrastructure, so this is given like it is shown in this figure here. You can see a substation could be of medium size high voltage or extra high voltage substation, and this could be the control center. You have a generating plants, again generating plants could be of thermal, nuclear or any other generating sources. So, from here the communication is generally done by various newer technologies which are being adopted. It could be a wide area network using LAN connectivity or a wireless connectivity, and further this communication is helpful in collecting the data and supplying it to the administration or the control arrangement. So, this could be of several layers where the data is being communicated and suitable arrangements are made to see that the monitoring of data and the usage of data and the remedial measures in case of the failures of the equipment could be done. So, various type of communicating cables could be of optical fiber link or it could be of wireless communication which is very helpful in the present day power utility communication networks. So, some typical design parameters which could be required for the power utility engineers is the important being the dependability. This has always the highest requirement. So, the dependability followed by the security have the highest possible dependability. Then you have the transmission time, the time communication should be the minimum as possible or the data collection should be the minimum time where the data could be communicated or data could be analyzed or data could be monitored. So, within a minimum possible time, and the transmission bandwidth which is required for the parameters for the transmission of power for a power utility may not be very critical, could not be very high also. So, the bandwidth again depends upon the system, number of parameters to be measured, number of connectivity, number of the voltage level and the devices which are connected, depends on the information of all these things. So, finally is the transmission media. So, whether what type of transmission media is to be employed for the power utility. It could be a fiber optical communication, it could be a microwave which is operating at a very high frequency, or could be power line carrier communication, or it could be a VSAT satellite based communication. So, power utilities have all this transmission media have been being used over the period of time. So, very important for the power utilities to properly choose the technology depending upon their required information. So, the main application requirements of the power utility, first of all it should be need to consistently transmit and distribute the electrical energy in the highest possible advantages highest possible way. The second being the various applications could be which will be helpful for the utility, particularly to ensure the reliable energy transmission and distribution, very important aspect. And some of the applications are very critical, there is a mission critical, very high importance. This could be the required real time communication, important communication data transfer, then requiring predictable and constant communication channels for the power transfer by the power utility personnel. So, very important applications which are required by the utility engineers.